Welcome to Algebra 2 2.6 video lesson. The concept is families of functions, and there are 6 boxes for us to talk about. Okay, in box number 1, I just want to make sure that we are all on the same page and when we say the word parent function. So a parent function is the simplest form in the set of functions. So as an example, I think all the ones that we should be familiar with is if I'm talking about the line y equals x, then I'm talking about the straight diagonal line that goes through the origin. If I'm talking about the parent function y equals x squared, then I am talking about the very basic graph of the parabola. If I'm talking about the parent function for the square root of x, then I am talking about you should have this basic shape in mind. It kind of looks, I call that the shark fin, because it looks like, if I go like that and then draw a little thing, it looks like a shark fin. But that's my own little thing. So anyways, this is the square root function, looks like that. The parent function for x cubed, it should look like a backwards s, and you should have that in mind. You should have that somewhat, that general shape. The absolute value function of x, the parent function is what we call the v graph, so it looks like this. And then the exponential graph of e to the x looks something like this, all right? So these are just basic, quick little sketches of parent functions. You should definitely have all 6 of these memorized in the sense that you have a general idea of what the shape looks like, all right? You don't necessarily have to have points associated with them, but you should have the general shape. So there they are in case you need them, and that's what I wanted you to get out of box 1, the understanding of a parent function. Okay, box number 2 is the notion of understanding what are called translations. So in this box, there are 2 types of translations I want to talk about. I want to talk about a vertical translation and a horizontal translation. A vertical translation is nothing more than moving the graph simply up or down, and a horizontal translation is nothing more than moving the graph left or right, okay? So if you are given any parent function, f of x, any parent function, it can be one of those 6 in box number 1 or any picture of a function in general. If I am taking my function, then I am adding a specific value to the end of it, then what that is, that's going to imply that I have a vertical translation. So if the a value is greater than 0, that implies that I'm going to translate my graph up. If my a value is less than 0, that implies I'm going to translate my graph down, okay? So I want you to be able to recognize it. So as an example, if I give you the parent function f of x is equal to x squared, and then I say x squared minus 3, then because I'm subtracting 3 from the end, that means I'm going to translate my function down 3 units. That's a very different story than this one over here, okay? And most students mess this part up. Notice the difference that the a value is actually inside of my function. I'm evaluating that a function, and I'm plugging in the a and then evaluating for f. So this, if my value of a is inside my parentheses, this is going to be a horizontal translation. So as an example, if I am graphing f of x is equal to the quantity of x squared, x minus 3 quantity squared, then this is going to be a horizontal translation, and it's going to be 3 units to the right. So in this case, if a is greater than 0, it's going to be left a units. And if my a is less than 0, it's going to be 0. It's going to be to the right a units. So I'll talk more about that. But I wanted to introduce the idea of vertical versus horizontal translations, and we will do an example in just 1 second. Okay, box number 3. I'm going to show you a very specific example of a vertical translation. So in the graph, you see this blue function, which I'm calling f of x. Kind of looks like a mountaintop. I have a bunch of points that I have labeled for you. And what we're going to do together, I'm going to show you how to do, is we're going to draw f of x minus 3 and then f of x plus 1. So I'm going to use the green pen to draw f of x minus 3. Now, because I am taking a value on the end and it says minus 3, I'm going to move my entire graph down 3 units. So instead of this point being at -2, 0, I'm going to move it down 3 units. 1, 2, 3. So this point is going to end up being here. I have translated this point down 3 units. I'm going to do that for every single point that I have. So instead of 0, 3, I'm going to go down 3 units. 1, 2, 3. So that point should go there. Down 3 units. 1, 2, 3. That point should go there. Down 3 units. 1, 2, 3. That point would be there. And down 3 units. 1, 2, 3. That point would be there. So this represents the graph of the function. In green, this is f of x is equal to, or f of x minus 3. excuse me, that's a graph of f of x minus 3. So if the blue one is f of x, the green one is f of x minus 3. Now in red, I'm going to do plus 1 for you. So this plus 1 on the end means that I'm going to move my graph up 1 unit. So this point is going to go up to 1 unit. This point would go up 1 unit. This point would go up 1 unit, up 1 unit, and then up 1 unit. So if I were to draw the red graph here, this graph is a representation of my original function f of x and then plus 1. So all I want you to be able to do is move a function up or down depending on the value added to the end. Okay, box 4 is a horizontal translation. So again, same setup. I have a graph that's in blue, which I'm calling f of x. It's not anything specific. It just happens to be a function that I made up. And what I want us to be able to is recognize, what does f of x plus 2 mean? It means that since my plus 2 is being evaluated in the function, it's going to make my graph go 2 units in the opposite direction of a positive 2. So that's going to be 2 units to the left because we're adding 2. So we would go 2 units to the left to get back to our original unit. So what does that mean? That means that, and since I'm dealing with a horizontal, this point, instead of at 1, 0, is going to move 2 units to the left. So it's going to be there. This point is going to move 2 units to the left. This point would move 2 units to the left. This point, 2 units to the left. And this point, 2 units to the left. So if I could actually draw this and replicate it, it would look something like this. And then come down and then up like this. There we go. So my red graph now represents f of the quantity x plus 2. I have moved that graph 2 units to the left. Reason it's to the left is because I would have to add back the 2 units to get me the original function. That's why it's the opposite of the way that it looks. Okay, let's do one more. Let's do the green one here. The green one says f of x minus 1. So because my value of a is being added into my function here, this is going to move everything 1 unit to the right. So from my blue graph, this point goes here, this point would be here, this point would be here, this point would be here, and this point would be here. So my graph would look something like this if I could draw it perfectly, which I'm trying to do, and then up like that. So my green one would be the representation of f of whatever x is, and then minus 1, okay? So we have horizontal and we have vertical translations, and the goal is that you are able to look at a function's description and tell which way the graph is going to move and by how much. Okay, box number 5 is all about reflections. I want to talk to you about f of negative x versus the negative of f of x, okay? So again, same setup. I have a graph for you in blue, which I'm calling f of x, which has these 3 points for you right here, so on the graph. And what we're going to do is we're going to draw f of negative x and the opposite of f of x, or negative f of x. So in green, if my negative is on the inside of my function, it's a reflection over the y-axis, So what does that mean? Well, here's the y-axis here, so I want to reflect this point over the y-axis, so it would have to go there. If I take 2, 4 and reflect it over the y-axis, then that point would have to be here, right? It'd be at negative 2, 4. And if I take 4, 1, reflect it over the x-axis, or the y-axis, it would end up being over here. So the graph would look something like this, and then down, and this would be the representation of f of negative x. It's a reflection over the y-axis. Now the red one, okay, if I reflect the graph, if I take the opposite of f of x, it's a reflection over the x-axis. So instead of 1, 2, I would have 1, negative 2. Instead of 2, 4, I'd have 2, negative 4. And instead of 4, 1, I'd have 4, negative 1. So my graph would look something like this if I could draw it perfectly, which I'm trying to do. So it would look something like that. So the difference between the two is important for this box. So if my negative is on the inside of my function, it's a reflection over the y-axis. If my negative is on the outside of my function, it's a reflection over the x. Okay, so box number 6 is a U-try, and you're going to have to just do this one in your notes. All right, so I have this graph here for you. I have 4 points on my graph, which I'm calling f of x. Your challenge in box number 6 is to draw the negative of f of x. So what is that negative on the outside going to do? Look back to box 5 if you need help, and show me your notes tomorrow in class. Okay, hopefully you got something that looks like this in your notes. Remember that a negative f of x is a reflection over the x-axis. So if you got something that looks like mine for the solution, you are doing a great job. All right, have a good day.